Hi friends, this is Selvajang here. Welcome to my networking channel. Hope all are doing good. And today the topic I'm going to discuss how to troubleshoot MPLS. So before that, I'm going to give a quick overview how MPLS work. So there are five routers, right? So PE1, PE and PE2 collectively called as the MPLS backbone routers. So PE1 and PE2 are at the provider end. So CE1 and CE2 we called as a customer edge router placed at the customer premises. So PE1 and PE2 are the provider router which is placed at the provider end, right? So this is collectively called as the MPLS routers. So this will be doing a label switching. So there are three types of mechanism. One is the label push, label swap, and label pop. So these three mechanism we call it as a LSR, label switch router. So that is the way it will be switching the labels between from source to this till this destination, right? So first the packet, unlabeled packet will be routed from CE1 to provider edge router, and at the transmitting end we'll be imposing a label onto the packet. So this label packet will again send from the provider edge router to the provider core router. So this is a core router which sits in between the PE1 and PE2. So this provider router will swap the label from 17 to 16 say. Then again it send the label packet to PE2. So at the receiving end it will just pop or remove the label and it will send only the unlabeled packet to CE2. So this is the actual MPLS process. And basic configuration, what are things we'll do is we'll configure first the VRF. So VRF we have to configure at both the configuration and at the interface level. So to always check the VRF first thing. So second thing, you have to check the RD and RT. So what is VRF is a virtual routing and the forwarding information. So a single global routing table, I'm just segregating into multiple virtual instance. So each and every virtual instance we called as a virtual routing and a forwarding table that is used to maintain the customer traffic and the routing table unique, right? So there can be several or millions of customers in a MPLS cloud. So how we can differentiate only by this VRF, and under this VRF I'll be configuring RD and RT. So RD and RT, both the format looks the same, but the purpose is different. So RD is a route distinguisher which is used to distinguish between two customers similar identical routes. What it means is, assume there are three customers, all are using the same prefix value. So in a normal routing environment, it will lead to overlapping, right? If you are using the same prefix at the transmitting and the receiving end, it can lead to overlapping. But in case of MPLS, we can prevent the overlapping. So it will prevent the overlapping prefixes by assigning individual labels, right? We can prevent it. So for that, we are using a identifier called RD, route distinguisher, and RT is for importing and exporting the customer routes. That's the purpose of RT. Then we'll configuring the LDP and IGP. So IGP and LDP, why I'm configuring together is IGP is the routing protocol, OSPF I'm going to use. So this routing protocol will trigger the label advertisement between the MPLS core router. For that reason, LDP we are using. So LDP is a label distribution protocol which is used for advertising and triggering the labels between the MPLS routers. So third thing, I will configure the MPBGP. So MPBGP is a way of advertising the VPN v4 route between the provider edge 1 and provider edge 2 router. So what is a VPN v4 route? It's a combination of prefix and RD. So it's sending the label packet, it'll be sending RD and prefix also. So the combination of RD and prefix we call it as a VPN v4. So for advertising this VPN v4, we'll be using this MPBGP between the PE1 and PE2 router. So the final thing what I'm going to do, this is the fourth configuration is I'll be configuring the IPv4 BGP between the customer edge and the provider edge router on both the transmitting and at the receiving end. So these are the basic configuration I'll be doing for MPLS. So at least we should know what is exactly the MPLS and what is the configuration. So then it will be easy for us to troubleshoot. And prior to that, we have to understand all the basic show commands of MPLS, right? So now let us understand. Now let us check the commands one by one. Why you are not saying the prefix? So the issue is this corresponding prefix not getting advertised in this routing table, and CN prefix, that is 1.1.1, it is not getting advertised in this CE2 BGP routing table. So now let us go and fix the issue. So let us go to PE1. First and foremost thing you have to check is always we have to check the VRF, whether there is a VRF mismatch. So what is the command is show IP VRF. So here the VRF is red and the RD value is 1:1. So let us check from PE2 also. Show IP VRF. So the VRF value is fine, right? RD, the VRF is red and the RD value is 1:1. The same thing is on both the things. Second thing you have to check always this corresponding interface, whether we are enabled the VRF on the interface. That also you check. So go to the second thing. So let us do one by one. Show run interface faster than 0/0. So here we configure IP VRF forwarding red. This is a command for enabling the VRF in the interface level. So that is fine. So let us check from PE2. Show run interface fast Ethernet 0 by 0. So this also we enable IP VRF forwarding rate. The VRF name is same. So now what to check? We have checked this also. Second thing, let us check the LDP has been established between all this router. So it should successfully establish the LDP neighbor adjacency with the neighboring routers. How to check it? Go to this PE1. Show MPLS interfaces. There are two commands. Show MPLS interfaces or show MPLS LDP neighbor. So the neighbor is coming up. 3.3 is up. This is the source address. So let us check from PE. Show MPLS LDP neighbor. So LDP, what is the purpose of LDP? First, it will dynamically discover the neighbors with UDP protocol. So once it establishes a neighbor adjacency, it's established using a protocol called TCP. So that's the thing you are seeing here. It has already established the TCP connection, and you are seeing the neighbor is coming. LDP neighbor is coming up. So the second configuration is also good, right? So first thing is we are verified. Second we are verified. And third thing, it's a mandatory thing we have to check between PE1 and PE2. So if this is not fine also, we can't see the prefixes over here, right, in the customer entry. So that's the thing I brought this video. Let us check now. PE1. What's the command for checking the MP-BGP? It is a way of advertising the VPN v4 route between PE1 and PE2. Show BGP VPN v4 unicast all summary. So I'm able to see 12.1, but I'm not able to see this prefix. So here what I have done. So this I have defined the loopback address 2.2. And the second thing, here I have defined the loopback address as 3.3. So here I have defined as 3.3. And this loopback address I have defined as 4.4. So I have communicated using I have configured the IP-BGP between this PE1 and PE2. So we have to see this neighbor 4.4.4 in a BGP neighbor relationship. But while doing this BGP VPN v4, I am not able to see the route. So what we have to do, we have to go ahead and configure the VPN v4 route. I am going to activate the MP-BGP. So how to do that? Go to the configuration mode, router. Before that, let us check the routing entry, right? CE1. So the routing entry at the CE1, I am not able to see this prefix. Similarly, let us see CE2 also. So CE2 also I am not seeing. So let us now activate the MP-BGP between PE1 and PE2. How to do? Router BGP 234. So it is established an IBGP neighbor. All these routers are in 234 autonomous system number. So that's the reason I'm configuring this. And the neighbor is 4.4.4. That's the loopback address. I'm going to establish this IBGP neighbor relationship using the loopback address. So the remote AS is 234 and the neighbor is 4.4.4. Update source loopback 0. Why this command is, since I'm establishing using the loopback address, this IBGP, I'm using this. After that, one more command is missing, that is address family. So this address family is a command we can configure IPv4, IPv6, VPN v4 or VPN v6. So it is support multiple families. So that is the reason purpose for configuring this address family, and for activating this MP-BGP or VPN v4 we are using this address family. So now define the VPN v4 route. Then let us do neighbor. This is a neighbor 4.4.4 activate, right? Similar way, let us go to PE2. Go to the configuration mode, router BGP 234, and the neighbor is, what is the neighbor is 2.2.2, right? PE2 to PE1. So go to PE2, neighbor is 2.2.2, and the remote AS is 234, and update source loopback 0. Update source loopback 0. Then go to the address family, activate the VPN v4 routes. Then neighbor is 2.2.2. We have to specify this command activate. Then only the neighbor will be coming up. So now I have done this configuration. There is one more thing is pending. We have to remove the IPv4 route. That means it is only establishing the VPN v4 BGP communication, that is MP-BGP between PE1 and PE2. So it is better safe to disable the IPv4. How to do that? Go to PE1 and go to the configuration, router BGP 234, make the address family as IPv4 and do no neighbor 4.4.4 activate. So this just we are disabling the IPv4. So this, it will not going to disturb the VPN v4 because we already established the VPN v4 using this address family command VPN v4. So just I'm disabling only the IPv4. Since I'm not using the IPv4 between PE1, PE2, I'm using this. So router BGP 234 address family IPv4 no neighbor 2.2.2 activate. Yeah. So you're done this. Now let us check the BGP routes. Show BGP VPN v4 route. I'm going to check now. So now you are able to see the neighbor is active, right? That is 4.4.4 is active and the MPBGP is active. Let us see here. So the MPBG is active. So now let us do a trace from PE1 to PE2. Trace is 4.4.4 source loopback 0. I'm able to reach, right? Similar way PE2 also do a trace, and what is the command is 2.2.2 source is loopback 0. So I'm able to do the trace from both the ends. That means MPBGP has been successfully established. So the third one is fine. So now we have to let us see whether you're able to see the entries here. So now I'm able to see the entries. Now you're understanding here the problem is you have to check always the MPBGP communication, and also you have to check the VRF name, and also the LDP neighbor relationship should be established between these routers, and the MPBGP should be successfully established between PE1 and PE2. So these are the basic things we need to check. These are the first preliminary 3 steps. After that, then we have to go with CE1 and CE2. We have to check for the IPv4 communication. So these are the basic things we have to troubleshoot while doing the troubleshooting the MPLS. So I'm able to see. Let us do from CE2. Show IP route. So I'm able to see the entry now. Let us do the trace now. Let us do the trace to 5.5. Loopback. This is a trace, right? 5.5.5. So 5.5.5 source is loopback 0. So now trace is working properly. Let us do from CE2 also. Trace C1 address is 1.1.1. Source is loopback 0. So now it is everything is working fine, and we are able to reach the communication MPLS communication from customer edge 1 all the way to CE2, and from CE2 we are able to trace from to CE1. So these are the thing you have to always keep it in mind, and you can see this trace exactly. First it will send the unlabeled packet, and at the train transmitting it will add the 2 labels. One is a transport label and this is a VPN label, and again it will send it to provider router, that is 45.1. So again we'll add the label. You can see here 12.2, right? This is 12.2, and then 23.2. What is happening? It is adding the label. Then it will again swap the label here, and it will send it to 45.1. This is the thing 45.1 IP. Then again it will come as a unlabeled packet at the customer edge router, that is 45.2. So this is the exact trace. So I hope you enjoy this video. Thanks for watching. Please subscribe for more videos. Thanks and have a wonderful day. Thank you.